average rate, then we have to use change in concentration but change in time. But here is the time taken, right? Yeah, let me do it. Instantaneous rate. What is instantaneous rate? The rate, the speed of the reaction at that instant, at that time interval. And the main important thing is that the rate is always positive. Rate cannot be negative. As the speed cannot be negative, rate also cannot be negative. And then the change in concentration by change in time equal to tan theta. We got this from this graph. What is this graph? It is the concentration and the time graph. If you see it, then from here if we draw imaginary lines, it forms a triangle. From that triangle, this is theta. From this theta we got the change in concentration by change in time equal to tan theta. You can see it, the opposite by adjacent. And then the factors affecting rate of reaction. The number one is concentration. You can see that the formula of rate is change in concentration by change in time taken. So concentration is directly proportional to concentration. And titration. If we titrate, first we are gonna see the rate, and then if we titrate it, it could change. So it depends on titration. Next factor is volume. It depends on the volume, because the concentration, if the concentration depends on the volume, so the rate of reaction also depends on the volume. Pressure. The pressure also depends on rate of the reaction. So it is also the thing. Yeah, let me rub it. Rotation of light. If you read isomerism, in isomerism topic, there are two types of rotation: dextro rotation and Lewis rotation. Lever rotation. So if the rotation of light changed, then the concentration changed. I think in the next class I will say you about it. pH. The pH decides the acidic nature, and acidic nature depends on concentration, and then it depends the rate of the reaction. And then the physical state. It's very important. The physical state depends the rate of reaction. If that is solid, liquid or gas, then it is dependent. So this is the one. And next, if we come, let me clear it out. Yeah, let me clear this all. Wait, let me clear this. Yeah. Yeah. Next, if we come to the next one, temperature. How temperature is dependent? Temperature is mainly dependent. About this, there is a big law. That's the main topic in the chemical kinetics, Arrhenius theory. I cannot write it clearly, but Arrhenius theory, right? Let me rub it out. Sorry. Arrhenius theory. So in the third class, I will say it, and then about the radiation. Radiation depends on the physical state, and physical state depends on the rate of reaction. So it's directly dependent on it. And these underlines say that they are all of one kind. And then if we come into the laws, the first law is the rate law. It's a main law. It says that the first rate equal to minus 1 by A into dA by dt. dA by dt is the concentration of that. Minus 1 by B into dB by dt equal to 1 by C into dC by dt equal to 1 by D into dd by dt. How did we got? From this equation. From this equation we got it. Right? Rate is proportional to A into X, A power X into B power Y. This is also rate law. How did we get it? That depends on the formula. Then what is X and Y? What is X and Y? What are those? X is the order with respect to A and Y is the order with respect to B. Yeah. Then how can we find it? We cannot find it, but they will give that in the question. Right? And then let me clear it out. What are the units of K? Units of K. What? Wait a second. What happened to it? I think we selected blank. Yeah. So rate equal to K into concentration whole power N. Let me put brackets here. K into concentration whole power N. The units of concentration is moles. Moles into whole power N. So the units of K can be defined as K equal to mole per N minus 1 into T per minus 2. These are the units of K. units of k. So guys, in the next class I will say about another laws, and in the third class I will say about the main thing, Arrhenius theory. So keep watching. Bye.